everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about problems on F distribution. In test of hypothesis for small samples, we have three tests. So first one is three distributions. So first one is T distribution, and second one is F distribution, and third one is chi-square distribution. In T distribution, we have two methods. First one is T distribution for single mean, and second one is T distribution for difference of means. And also in F distribution, so the F distribution definition is F distribution to test whether there is any significance difference between two sample variances. To test whether there is any significance difference between two sample variances S1 square and S2 square, we use F test. In F test, the test statistic F is given by F equal to S1 square by S2 square, where S1 square is greater than S2 square. Or we can use one more formula, that is F equal to S2 square by S1 square, if S2 square is greater than S1 square. So where S1 square equal to 1 by N1 minus 1 in N1 minus 1 into summation I equal to 1 to N xi minus x1 bar whole square, comma S2 square equal to 1 by N2 minus 1 summation I equal to 1 to N xi minus x2 bar whole square. So these two are S1 square, S2 variances formulas. First problem. First problem. Two random samples gave the following results. Sample 1, 2, sample size 10, 12, sample mean 15, 14, sum of squares of deviations from mean. Sum of squares of deviations from mean is 90, 108. So sample sizes are denoted with N. So we know that the first thing you need to remember, so population, and this is sample. So population size, and this is sample size. So population size is denoted with capital N and sample size is denoted with small n. So population mean is denoted with mu, and the sample mean is denoted with x bar. So population variance is denoted with sigma square, and sample variance is denoted with s square. So population standard deviation is denoted with sigma, and sample standard deviation is denoted with S. So first of all, you need to remember these points. Okay. So, but the most important thing is here you need to remember this sample size, sample mean is denoted with x bar, and sample variance is denoted with s square, and sample standard deviation is denoted with s. Okay. So in this case, these sample size is denoted with n. Sample size is denoted with n. So that's why this is n1 value and this is n2 value, because here we have two values, right? So that's why n1 equal to 10 and n2 equal to 12. Sample mean. We know that the sample mean is denoted with x bar. Sample mean is denoted with x bar, and sample mean is denoted with x bar, and here we are having two values. That's why this is x1 bar and this is x2 bar. So x1 bar equal to 15 and x2 bar equal to 14. Next, sum of squares of deviations from the means. So that is summation, sum of squares of deviations from the means is denoted with the sum of squares of deviations from the mean, that is xi minus x bar whole square. Summation xi minus x bar whole square. So sum of squares of deviations from means is denoted with summation xi minus x bar whole square. So here we have two values now. So that's why that is summation xi minus x1 bar whole square and summation xi minus x2 bar whole square. Okay, so see, observe carefully whether it is small sample test or large sample test. So observe carefully whether it is small sample test or large sample test. So if n is greater than or equal to 30, then we can say that that is large sample. If n is small n is less than 30 or the sample size is less than 30, then we can say that that is small sample. Small sample. So here we have less than 30. So that means sample size n1 equal to 10 and sample size n2 equal to 12. That means both are less than 30. So that's why this is a small sample test. Small sample test. Okay. Small sample test. So now coming to the question, test whether the samples came from the same population or not. So here we need to check these samples came from the same population or not. So in this case, given n1 is 10, n2 is 12, and x1 bar is 10, and x2 bar is x1 bar is 15, and x2 bar is 14. x2 bar is 14. So sum of squares of deviations from the first mean is that means summation xi minus x1 bar whole square equal to 90, and sum of squares of deviations from the second mean is 108. That means summation xi minus x2 bar whole square equal to 108. So n1 equal to 10, n2 equal to 12, x1 bar equal to 15, and x2 bar equal to 14. So summation xi minus x1 bar whole square equal to 90 and summation xi minus x2 bar whole square equal to 108. So we need to find s1 square and s2 square. Okay. So s1 square equal to summation xi minus x1 bar whole square divided by n1 minus 1. So this is our formula. So s1 square equal to summation xi minus x1 bar whole square by n1 minus 1. So summation xi minus x1 bar whole square is 90. So 90 divided by n value. So what is n value? N1 value. N1 value is 10. So that's why this is 10 minus 1, right? So that is 9. So 90 by 9, that is equal to 10. So therefore S1 square equal to 10. Like that, S2 square equal to, we have a formula that is summation xi minus x2 bar whole square by n2 minus 1. So S2 square formula is summation xi minus x2 bar whole square by n2 minus 1. So we know that summation x2 minus summation xi minus x2 bar whole square is 108. So that is 108 divided by what is n2? n2 value is 12. So 12 minus 1, that is 11. 108 divided by 11, that is equal to 1.81. So therefore S2 square equal to 9.81. Okay. So which is bigger value? S1 square is bigger value. That's why we have to write in the numerator in F distribution formula. Okay. So now coming to the first step. Our first step is null hypothesis. So always null hypothesis is denoted with H naught. Null hypothesis. Always the null hypothesis is denoted with H naught, that is equal to S1 square equal to S2 square. So here what is the meaning of S1 square and S2 square? So there is no difference. There is no difference between sample variances. So S1 square equal to S2 square. The meaning of this one is there is no difference between sample variances. Like that, alternative hypothesis. Alternative hypothesis is denoted with H1. So what is the meaning of alternative hypothesis? Alternative hypothesis is nothing but opposite to the null hypothesis. Opposite to the null hypothesis. So here I am taking S1 square equal to S2 square. So in alternative hypothesis, we need to take S1 square not equal to S2 square. That means there is a difference between sample variances opposite to the null hypothesis. In the null hypothesis, I have taken that there is no difference between the sample variances. But in the alternative hypothesis, here I am taking there is a difference between sample variances. Okay. So next, coming to the level of significance. So here they have not mentioned alpha value in the question, right? So that's why here I am assuming that the alpha value is 0.05. The alpha value is 0.05, assume. Okay. So now we need to find the F alpha. So what is level of significance here? So here F alpha at n1 minus 1 comma n2 minus 1 degrees of freedom. So n1 minus 1 is nu1 and n2 minus 1 is nu2. Okay. So we need to find F alpha at nu1 comma nu2 degrees of freedom. Actually, we need to find F alpha at nu1 comma nu2 degrees of freedom. But we have nu1 equal to n1 minus 1 comma nu2 equal to n2 minus 1. So nu1 equal to n1 minus 1. So that means, so what is the value of n1? So n1 is 10. Okay, 10 minus 1 comma n2 value is 12. 12 minus 1. So F alpha value is 0.05. So F alpha at nu1 comma nu2 degrees of freedom. So that means the degrees of freedom. Degrees of freedom. So therefore, F 0.05 at nu1. So at 9 comma 10 minus 1 is 9 and 12 minus 1 is 11 degrees of freedom. Okay. So that means the nu1 value is 9 and nu2 value is 11. Okay. So these are all nu1 values, and these are all nu2 values. Okay. So nu1 is 9 and nu2 is 11. Some distribution tables, nu2 is this one, nu1 is this one. Okay. So based on that, you can take the values. The value is 2.90. Okay. So we have to take this from F distribution table. F distribution table. Okay. So we have to take this value from F distribution table. F distribution table. Okay. So therefore, F alpha value is 2.90. So test statistic. So coming to the test statistic, here we have S1 square value is 10 and S2 square value is 9.81. So S1 square value is bigger value than S2 square. So that's why we have to write S1 square value in the numerator. So because S1 square is greater than S2 square. Okay, so that's why S1 square you have to write in the numerator, that is S1 square value is 10 and S2 square is a smaller value, that's why we have to write in the denominator, that is 9.81. So 10 divided by 9.81 we will get 1.018. So this is F value, but we need modulus of F value, modulus of F equal to 1.018. Now coming to the last step, conclusion. Therefore, modulus of F is less than F alpha, because the modulus of F value is 1.018 and F alpha value is 2.90. So 1.018 is less than 2.90. So that's why modulus of F less than F alpha. So that means the calculated value is less than tabulated value. The calculated value is less than tabulated value. So therefore, we accept the null hypothesis. If modulus of F is less than F alpha, then we can accept the null hypothesis. That means, so what is the meaning of this one? There is no significance. The given statement is truth statement. That means there is no significance difference between the sample variances. There is no significance difference between the sample variances. So exercise problem. So here we have exercise problem. The problem is pumpkins were grown under two experimental conditions. Two random samples of 11 and 9 pumpkins. The sample standard deviation of their weights are 0.8 and 0.5 respectively. Assuming that the weight distributions are normal, test hypothesis at true variances are equal. So variances is nothing but we have to use F distribution. So the F distribution formula is S1 square by S2 square, where S1 square greater than S2 square, are F equal to S2 square by S1 square, where S2 square greater than S1 square. Okay, so two random samples, N1 equal to 11 and N2 equal to 9. Okay, so the sample standard deviation of weight as weights are 0.8 and 0.5. That means S1 square standard deviation, S1 standard deviation is denoted with S1. So that means here N1 equal to 11 and N2 equal to 9, and S1 standard deviation, sample standard deviation is denoted with S1. Yes. Okay, sample standard deviation is denoted with the S. Here we have two values. So that's why S1 equal to here 0.8 and S2 equal to 0.5. That means this is S2 value. Okay, so which is bigger value? S1 square is, so that is 0.61 and this is 0.25. S2 square. Okay, so which is bigger value we have to write in the numerator. So after that we have to follow the same procedure like F distribution for first problem. And the second problem is the measurements of the output of two units have given the following results. Assuming that both samples have been obtained from the normal population at 10% significant level, test whether the two populations have the same variances. Variances is nothing but we have to use F distribution. Okay, so unit A is this one and unit B is this one. Okay, so let us consider these are all xi values and this is x. These are also xi values. Okay, so this is xi value, or you can take this is yi value. Okay, so from that we can find xi bar, x bar, and this is from we can find y bar. Okay, so summation xi minus x bar whole square. From this we can find summation yi minus y bar whole square. So we have formula now. So S1 square equal to 1 by N1 minus 1 into summation xi minus x1 bar whole square, x bar whole square, and S2 square equal to 1 by N2 minus 1 into summation yi minus y bar whole square. So from that we can find S1 square and S2 square. So F distribution formula is F equal to S1 square by S2 square, where S1 square is greater than S2 square. Or we can take F equal to S2 square by S1 square, where S2 square is greater than S1 square. Okay, so like that follow the procedure. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.